Hey, we made it. This is it, 3.5, the end of chapter 3, which is also the end of module 1. So after this, you guys will have all assignments, all quizzes. You need to get all that stuff done and start prepping for that exam 1. We did it, module 1, all done. Let's do this. So 3.5 is all about what we call box plots, okay? Box plots, pretty straightforward and simple for us. You also know these by another word or another set of words, which we call box and whisker plots. Okay. We were going to learn box and whisker plots on StatCrunch. You can do box and whisker plots on the calculator, but StatCrunch is a little bit more versatile and provides a little bit better utility for box plots. Okay. Box plots are composed of what we call a 5-number summary, the minimum value, quartile 1, quartile 3, the median, and the maximum. Okay. And again, all these are the same 5-number summary that we have talked about before when we did section 3.3 and you guys ran, on the calculator, the one variable statistics, and the same thing that we ran in StatCrunch, where you guys ran the statistics to find the standard deviation and the median and all that stuff. This is that same 5-number summary where you can get that information from. So again, you do not have to do this by hand, although the data that we're working with is not really too large that you could do it by hand if you want. But why do it by hand when you pay for StatCrunch and it's a part of the class, and I am urging you and encouraging you to use it. All right. So now just some notes about box and whisker plots. Whiskers will extend to the most extreme data values that are not potential outliers. Okay, so in this section 3.5, we're really going to hammer outliers on home. Okay, you're going to get a formula for how to distinguish if you have potential outliers. So we're not really just going to call them outliers flat out. We're going to call them potential outliers because they could have the potential to actually not really be outliers depending on your data. Okay, so that's going to be very important in this section where when we hammer this home and you get a formula for figuring out if you possibly have an outlier, that we take some due diligence on our part to look and explore about the outliers that you might have discovered. Okay, know that the displays can be vertical or horizontal. Most of the time we draw them horizontally, but they can be vertically. The default in StatCrunch is vertical box plots, just so you know. It's best to use them with unimodal distributions, okay, having one mode for the distribution. And more specifically, this works for any kind of distribution. Your distribution could be symmetric, right skewed, left skewed, and you can draw a box plot for all 3 of those, okay? But it's best to do it with unimodal distributions because box plots hide bimodal and multimodalities, okay? So when you actually look at a box plot, you won't know the general rule of thumb is that it is unimodal if you're looking at a box plot. But if you get a box plot from the very beginning, and maybe they use it for a bimodal or multimodal distribution, you won't know that just by looking at the box plot. It's hidden from your view. Other things about the box plot is we do not use it for small sets of data because, again, we got to have a 5-number summary. That means each one of these should be different numbers. So that means you must have at least 5 different data observations. Okay, we do not draw a box plot, unless our data has at least 5 different observations. Okay, it's super important. Anything less than 5, there's no point for a box and whisker plot because your 5-number summary will be really weird. Okay, trust me. All right, so let's take a look at some things that I was talking about. So right here, you've seen this data before when we talked about Olympic marathon runners versus amateur marathon runners. So this is a bimodal histogram. But when you look at the box and whisker plot over here, you don't see that. This is what I was talking about, how the box plot, it hides modalities. Okay, so in general, if we do a box plot, we want to do it for unimodal modalities, okay? Because in here, you can't see anything as far as the modality goes. You won't know that information, no matter what. A box plot hides that. Also, you can see kind of like some of those features I was talking about, how we kind of talked about the whiskers extend to the most extreme data observations that are not outliers. So this data does not have any outliers. You can see there are no gaps here, right? Okay, so there are no outliers over here. So you can see that our whisker from quartile 3 extends all the way out to the highest value that was recorded here. And then our bottom whisker extends out to the lowest data value that was recorded within here. Now, just some other things, kind of as I already related to, you can see the 5-number summary up here. This is the minimum value right there. This line right here, the beginning of my box, represents quartile 1. The middle line inside the box is the median, middle. This line right here that ends the box is quartile 3, as I said a moment ago, and right over here, this is the maximum. So you can see all 5 numbers right here. Minimum, quartile 1, median, quartile 3, maximum. Now, just some other pieces of information. Know that you see how this is kind of separated into 4 pieces. You got the bottom whisker, the first half of the box, the second half of the box, and then the top whisker. Each one of these sections, 1, 2, 3, 4, is 25% of your data. It doesn't matter how long it is 25% of your data. So this little section right here is 25% of my data. This long section right here is 25% of my data. Okay? Also know that the box, this span right here, this is actually the interquartile range. This is the lowest, quartile 1, quartile 3. This right here represents the interquartile range, and that the box is proportional to the interquartile range, okay? The box is proportional to the interquartile range. Remember, the interquartile range represents the span of the middle 50. So this is the middle 50% of my data, okay? 25%, 25%, totals 50% there. Okay, just wanted to show you some features of that if you've forgotten about box and whisker plots. So now you know where some of this information is coming from. I've got another picture here, or actually no, I don't have another picture here. These is an old set of notes. So let me do a quick change real quick. I apologize about this. Let me jump in here. I thought I brought the new one out here. That one's junk. So let's grab this guy. Yeah. I apologize for this. I thought that was the new one. So let's open this back up. Let's get back to where we were. Just give it a moment, thinking about life. There we go. All right. So back to where we were. Okay. So here you can see a box and whisker plot. Here's what a potential outlier looks like. They put a dot there. But again, like I said, it's going to be our due diligence to start looking at potential outliers, because potential outliers, the reason why we call it potential, because if we look at our histogram right here, this is the histogram of this same data. This point right here represents South Africa's 8th grade, achievement score. In the box plot, it would label it as an outlier. But if you look at our histogram, do you see gaps here like what I talked about a moment ago? No. So I wouldn't consider this an actual potential outlier or an outlier. I would consider this a part of my data because my data is all connected here. There's no gaps. Okay? So I would not consider this an outlier. I would have my bottom whisker go all the way out to that dot. But speaking of which, so that you can see this, since this is an outlier, a potential outlier that they labeled, you can see that our whisker doesn't go all the way out to it. It goes out to whatever data value entry was this one. Okay, so there was a cutoff score that they figured out, and this value was below that cutoff score, and this value right here represents the highest data value close to that cut score. That's where this whisker ends at. And I'm going to show you what I mean by that here in a second with an actual example. But that's what I mean when I talked about it in here, that whiskers extend to the most extreme data observations that are not potential outliers. When I give you that formula for potential outliers, it's going to give you a cutoff mark, and your whiskers will go all the way up to a value that is close to that cutoff mark or at that cutoff mark if it's in our data. All right. Again, I'll explain that here in a second. But also, as I said a second ago, it's going to be important for us from here on out that now if we discover a potential outlier, we really take a chance and look at it. Like, this guy should not be an outlier. It should have connected all the way to it. Because if you look at the histogram, or if you look at a dot plot, it really is a part of the data. There's no gaps, as what we talked about before with outliers. Okay? So let's talk about those potential outliers and, highlight some of the stuff that I just talked about. Potential outliers, here's the definition for them. Observations that are a distance more than 1.5 interquartile range below quartile 1 or above quartile 3. So in other words, here is the formula. Take quartile 3 and add 1.5 times the interquartile range. Take quartile 1 and subtract 1.5 times the interquartile range. And these will give you your cutoff marks. This will give you the upper cutoff mark. This will give you the lower cutoff mark. Any values that are above this one or below this one are what we call potential outliers. But again, like I said, we're not going to automatically call them outliers because we need to explore them. Okay, we need to look at that histogram and dot plot like I showed you right here. Okay, in the histogram and a dot plot, it would show you that this probably really isn't an outlier. There's really no gaps there. Okay, or the other thing that could have happened is it could have been a mistake. Did we write down something wrong by accident? And then can't we fix it and make our data reflect that? Absolutely. If it's a mistake, we can correct it and then go back and fix our data. That's all right. But we wouldn't know that unless we explore it, okay? And check things out and make sure that, oh, this was accurately taken or this was a mistake. And if it really is an outlier, well, then that, leads us to some other questions that we can explore. Is this something unusually unique or special about our data? Okay. Did we find out something that could happen that we didn't think was possible? So that's what's even cool about this. Maybe it's not really, an outlier, or maybe it is, and is it something special? Okay? These formulas up here help us, figure that information out. All right. So, stat crunch time. Let's do this. So right here, we have the number of entertainment, social media, and/or game apps on your phone. You guys provided me this data. Just so you know, the last one, number 50 here, that's my data. Again, don't judge. I've got kids. They like to play on my phone. They need to be entertained. So that's why I have 50. They're not really, I don't do social media, so they're all pretty much entertainment and games. Okay, so I have their games and entertainment. I have mine. I have Netflix and all that stuff. I got to keep my kids entertained somehow. And usually they grab my phone in the car. So that's the explanation of my number. But here we've got 18 values. Okay. And again, the first thing you can do, you can actually go into StatCrunch or on your calculator and put this information in, and you can get that 5-number summary. Okay. I already taught you how to do that. I can tell you the minimum value of this is 1. Quartile 1, the value is 6. The median ends up being 11.5. Quartile 3 is 20. And the max is 70. So again, we could have figured all this out by hand, but again, I'm lazy. I'm going to let my calculator do. I'm going to let, StatCrunch do the work because I'm paying for StatCrunch. Let's use it. So right here, here's all that data that I talked about, 18 of them. And again, you can get that 5-number summary by going to Stat, Summary Stats, and Column. Select Apps, and say Compute. And there's that 5-number summary you got. The minimum is 1, the maximum is 70, quartile 1 is 6, quartile 3 is 20, the median is 11.5. From this, we can quickly figure out the interquartile range. Okay, we can figure out the IQR. So the interquartile range, pretty easy. Interquartile range would actually be 20 minus 6, so 14. And now we can figure out the lower potential outlier value. And we can figure out the upper potential outlier value. So all we're going to do to figure out the lowers, we'll take quartile 1, which is 6, minus 1.5 times 14. Well, 1.5 times 14 is 21. 6 minus 21 is negative 15. So what this means is any student that has below negative 15 apps on their phone is a potential outlier. And again, this is weird. Again, think about it in terms of the context that you're dealing with. Is it possible to really have negative 15? No, I don't even know what negative 15 apps would look like on a phone. That's just plain simply weird. Okay? So when you look at some of these outliers, or, these values, does this make sense within my data? No. Technically, the lowest my data values up here could have been is 0. Okay? But again, just kind of taking this in context of what you just found is, if someone in the class had negative 17 apps on their phone, they would be a potential outlier. If they had negative 23 apps on their phone, they would be a potential outlier. If they had negative 15 apps on their phone, they would not be a potential outlier because they are on the cutoff. Okay? So, since this is the cutoff for potential outliers, if I find my lowest value, which is 1, that means since this is not below that, I don't have any lower potential outliers. There are none. So that means my bottom whisker will actually extend to 1, the minimum. And that's A-okay. Okay? So that's what I was talking about back here at the beginning, how your whiskers extend to the most extreme data observations that are not potential outliers. Okay? So that means in here, my lowest value is 1. That's not outside the negative 15, so that's where my whisker will end. Okay? Now, the upper, if we look at that, we'll take 20 plus 1.5 times 14. Again, 1.5 times 14 is 21. 20 plus 21 is 41. So our upper cutoff score is 41. Anybody above 41 is a potential outlier. And we actually have 2 of those. 70 and 50. Well, I already explained mine, so we know this is not a mistake. This is truly an outlier for us. Okay? If we looked at a histogram and a dot plot, which we can here in a second, when I show you that on StatCrunch, you'll see that we definitely have gaps. So this is truly an outlier for us. Now the 70, I would be interested to know about that student's phone and everything. Is that what they just use for everything in their life? That would explain it. Or maybe it could be a mistake. Who knows? This would be something that we would definitely have to explore further. But without that information right now, I'm going to say that 70 and 50 are both outliers. So they would be dots on my box plot. So where would my upper whisker end? Well, what is the highest value before 41? So if I look through, my highest value before 41 is 26. So that means my upper whisker will stop at 26. Okay? So that's what it means by the whiskers extend to the most extreme value that are not potential outliers. This is the most extreme value that is not a potential outlier on the upper end. Okay? So you might have to, in your homework, figure out the upper and lower limits. But other than that, let the calculator, let StatCrunch do the job for you. So let's go look at some things. So again, we could look at a histogram for this. Histogram, apps, compute. So you definitely see that there are gaps there. So we are correct in assuming that these are outliers. Okay? So let's actually look at a box plot. All right? So if you go to graph, right down here, it says Boxplot. So hit Boxplot, select apps. Okay, some other things that you can do. Again, I don't mess with a lot of things. Right here, this is going to use, this is already selected, this means that it's going to perform that outlier formula that we saw. Okay, StatCrunch is automatically going to recognize that 70 and 50 are above this 41. Okay, so this box right here means that it's going to apply that outlier formula. If you unselect it, then there will be no formula applied. Okay, the whiskers will go all the way down to 1 and all the way up to 70. I'll show you that here in a moment. As I said, the default for box and whisker plots is vertical. If you want it drawn horizontally, click on the horizontal. So hit compute. And there's our box and whisker plot. Like I said, if you come out here and start hovering on things, okay, it gives you some nice information about your box and whisker plot. You can see the number of values was 18. The number of outliers is 2, which we talked about. The interquartile range, it told you right there, was 14. The lower limit 1, quartile 3 is 26, or is 6. The median is 11.5. Quartile 3 is 20. The upper limit was 26. Okay, so that's that value that I told you before. That's the largest value before the outliers. Okay, so you can see all that information just hovering anywhere you want over it. All right, so again, there's our box and whisker plot. And again, each section up here represents 25% of the data. And then you can see our 2 outliers. Let's do some edit real quick, just show you some other things. Here's what it will look like vertically. There you go, just vertical. Here's what it looks like if you don't use the outlier formula. Like I said, it extends all the way out to the 70. And again, you can see the 5-number summary there. The max, the min, quartile 1, the median, quartile 3. Doesn't say anything about outliers because there was no formula applied. Okay? So there you go. Let's go back and take a look at this in its normal view. Because normally we like to draw these things horizontally. So there we go. There's our data as a box plot. Okay. So let's go back. So that just verifies all this information that you saw right here. Again, the only thing that it doesn't tell you out there is what that the lower potential outlier limit is and the upper potential outlier limit. You have to figure those out. But you just using that formula, StatCrunch gives you all the other information you needed. Okay? So let's take a look at your homework. Some things that you're going to see. I got 3 problems. So down below it says the box plot shows the brain size in hundreds of thousands of pixels for 20 men and 20 women. Estimate the numerical values of the medians by using the box plot. Do these men or do these women have greater variation in brain size? All right. So the median, remember, is the middle line. So it looks like the median for ladies is probably about 8.6. It looks like it's just a little bit above 8.5, so 8.6. Again, remember that this is all multiple choice, okay? And then the median size for men looks like 9.5, okay? So men versus women definitely have the bigger median size. Now, when it comes to variation, okay, this is where you can look at the entire range from the biggest to the smallest, biggest to the smallest, and look at the range. How spread out is the data? Okay, because that's going to be important. Because obviously you can see that the men, their brains appear to be a little bit bigger than women, but the thing that you need to compare, you can't compare 9 to a woman that's 8. Okay, when we talk about variation, we're talking about the spread. So that's where you might want to look at the range. And notice the women have a little outlier right there. Okay, so I would look at the range of these. Maybe you want to look at the interquartile ranges too, because this is the middle 50% of the data. So if you kind of look at this and you look at the women, the lower, if we want to go the full range, the lowest is at 8. I'm not going to include the outlier. The highest is at 9.5. So that means the range for the women is 1.5. They span a distance of 1,500,000 pixels. Okay. Men looks like they start at maybe, I'm going to go 8.8. And then they range all the way up to, it looks like about, I'd say maybe 10.7. And that is a range of 1.9. So I would say the men have a greater variation in brain size because they have the larger range. And the same thing if you look at the interquartile range. The men's interquartile range is just a bit bigger than the women's. Okay? So there's some, kind of food for thought for you. All right? So kind of look at, when they talk about variation, look at the range. All right? Nothing crazy there, promise. All right? So let's take a look at this one. So this one, I need to actually expand the page for you. So in here, they're giving you box plots up here, C, M, and P. And they want you to match the C, M, and P with the diagrams down below. Okay? So start thinking about some of those features. So right here, remember, these are outliers. So C should be pretty easy to identify because we need a histogram that has gaps. And that means C should match up with Y because in here you see the gaps. There's a big gap here. And plus, these are out here at 18, and this guy looks to be like maybe 17, could be 16. So that explains these two dots right there. So C and Y definitely match up. All right, now let's look at everybody else. Okay, so if you look at this guy right here, remember, this is the lowest and this is the highest. So M starts at 4 and ends at 12. I need a histogram that has bars from 4 to 12. And if you look down here, that's X. So M matches up with X because if you look at that middle, or sorry, not the middle values, but the minimum and the maximum, this matches that. Okay? Plus, if you kind of look at the median, it says the median is right here about 7. And if you look down here, 7 is right in here. So this is about the middle of my data, and that makes sense. Okay, and then down here, if you look at this, the data is real tight together. So the box plot for this is going to be real tight together. There's not a lot of variation here. Notice it starts at 3 and it ends at about 6. Notice this box plot starts at 3, ends at 6. So, obviously also by process of elimination, we know that P matches graph Z. Okay? So you'll have a question like that. And again, it's multiple choice, and the explain your reasoning is a part of the multiple choice. So all that information that I just told you, that's what you need to be looking for. And then last but not least, it says the dot plot shows the distribution of passing rates for the bar exam at 185 law schools in the United States in 2009. Here's a 5-number summary. So it says, draw the box plot and explain how you determine where the whiskers go. Okay. So when you do this one, you already know the 5-number summary up here. But the thing that you have to be careful of is you got to look at potential outliers. And you can see that we might have some potential outliers up here. And we need to discuss that and think about that. Okay? All right. So we need to first find those limits, those cutoffs. Okay? So your 5-number summary goes in order. This is the minimum. This is quartile 1. This is the median. This is quartile 3. This is the maximum. All right? So first, we need the interquartile range. So we're going to take 90 minus 80, which is 10. Okay? So to find the lower potential outlier, we're going to take the minimum, quartile 1, which is 80, minus 1.5 times 10. Okay? So 1.5 times 10 is 15. 80 minus 15 is 65. And there we go. So anybody below 65 is a potential outlier. So if we're looking up here, 65, 1, 2, 3, 4, probably right about there. So all those dots are below that are potential outliers, and we'll talk about that here in a second. Okay? Next, let's find the upper potential outlier. So we're going to take 90 plus 1.5 times 10. Well, remember that 1.5 times 10 is 15. So 90 plus 15 is 105. So if we look up here, the highest you can get on the bar exam is 100. So we're not going to have any upper potential outliers. It's really the lower ones. Okay? So when I talk about the bar graph for this, obviously your maximum should be at 100 because it looks like some people scored at 100. And then it's going to go down and you're going to have your box, which this is at 90. This is at 80. And in here is 86. And then obviously we're going to have our bottom whisker here. Now here's the thing. Here's what you got to watch out for. If you look at this data, I mean, I would say that we really only have 2 outliers. Maybe this clump of 3 if you wanted to consider it. Maybe. Okay, again, it's a little subjective. But I would consider all these dots that are right here a part of the data. Okay, even though this right here represents the lowest limit, it says, but I don't consider these outliers to that because it's a part of our data. There's no gaps there. The gap really starts after this. Okay, so I would have maybe my lower whisker go all the way over to 60. And then after that, I put in my dots. If that makes sense. So I would be looking for a box and whisker that looks like this, and then the explanation of how I determine the whiskers. Okay, with all the information that I talked about right here. That's how I would approach this problem. Because again, I consider this a part of the data. There's no gaps there. It's a part of the data. Okay? When we really get into the gaps, really kind of starts a little bit after that. Again, these are subjective. Maybe you want to consider them a part of the data. Maybe you don't. That's going to be your call. Okay? But again, this is multiple choice, so you'll be able to know what's going on when you look at the multiple choice answers. You're not actually going to be drawing this all by yourself. Okay? But I did it on here just to kind of talk about things that are going on. So that ends section 3.5. So you have all of chapter 3 to do. The 3.5 questions really start from section 41 to 47. And that ends chapter 3, and that ends all of module 1. Thanks for stopping by.